Okay, let us discuss this problem. This problem is related to Fermat principle of least time. So let us write. So problem says something related to Fermat principle. So Fermat principle of least time. You have to keep repeating, you have to keep writing also least time. So you keep writing, you assume this is just like a lecture. Now this problem says a ray of light traveling with a speed of c leaves a point A in figure given here. So let me first draw the figure so that things becomes easy. So I have here a surface. This is basically mirror. Now the length of from here to here, so mirror is slightly big. Let us say length from here to here we have, that is given. This length is L. So the length from here to here, this point, now we have a point just perpendicular here. We have a point, they call it 1, point P. Let us call this point as 1. Now this distance is also given, this distance is y1. So from here to here, the perpendicular distance is y1. Now a light ray comes here and meets this plane mirror at an angle of theta 1. So this angle is given. This angle is theta 1. So you have to keep writing. Now this reflects at angle of theta 2. So this goes at angle of, so this angle they call it theta 2. Now there is a point 2 and it does not specify whether this point 2 are in the same plane of point 1. So this means in the proof it is not required. Now this distance is given, this distance is by 2. This distance is by 1. So let us say this distance is by 1 and this distance is by 2. They call this distance from here to here x. So let us say this distance is x. Now the total distance, this is L. So let us make something bigger. So this distance from here to here, this distance is L. Now this point is called point 2. Now the question is asking, a light ray is traveling with a speed c. So speed of light ray is c. So c is the speed of light. A speed of light. So speed of light is given, this is c. Now the question says, is if leaves point 1 and is reflected to point 2. So point 1, it leaves the point 1, ray leaves the point 1 and reflected by this mirror and goes to point 2. So light rays is something like this. The rays strike the reflecting surface on a horizontal distance x from point 1. The distance from here to here, that is horizontal distance, is x. So that the time t required for light to travel from 1 to 2 is. So you have to prove the time required from 1 to 2 will be t is equals to under root y1 square plus x1 square. Okay, let me write here because we don't have so much space there. So time is y1 square plus x square under root plus by 2 square plus L minus x whole square divided by c. So we have to prove that this is the time that is required to go from 1 to 2. This is obvious. Now see, this distance is y1. This distance is x. So this distance is nothing but root over y1 minus y1 square plus x1 square. So this distance, so let us say PO 102, or you can say POM. So distance PO is nothing but under root x square plus y1 square. So distance is this, time from P to O will be distance by velocity. Distance is x1 square plus y1 square and velocity is c. Similarly, OM distance will be nothing but root over x square. No, this is L minus x square. This is x, so this is L minus x. So I have to write, and this distance is by 2. So I can say, so you can, are you see or not? This distance is by 2 and this distance is nothing but L minus x. So let me write here. So this distance is L minus x. So this distance is by 2 whole square plus L minus x whole square. So I can write by 2 whole square plus L minus x whole square. So this is the time t2, that is ray requires this time to travel from O to M, that is by 2 square plus L minus x whole square by velocity of light, that is given as c. Now next we have to prove the total time is t1 plus t2. So total time is t1 plus t2. This is same as what we have to prove, this distance. Now c is common, so t1 c, if I take c common, I will get the same thing, x square plus by 1 square plus L minus x whole square plus by 2 whole square and divided by c. So we are getting the same thing. Now the question second part says, take the derivative of t with respect to s and set this differentiation 0. This will give theta 1 is equals to theta 2. This is an example of Fermat principle of least time, which states that among all possible paths between 2 points, path actually taken by a ray of light is that for which the time travel is minimum. Now you see, we have to basically prove the law of reflection. Now there are many paths by which light ray can go from 1 to 2. It can go from here to here. So this will be one path. This will be another path. This will be another path. So there are so many paths available for this light from go 1 to 2. But the Fermat principle says light ray will choose the path that will take least time. So this means this point to this point and this point to this point, this is the path of minimum time. So this time is minimum. So if I say Fermat principle, this time has to be minimum time. Now if this time is minimum, now x is variable. You see, I can change the x and I can get the different path. If this light ray strikes here, you will have different x and then goes here. If light rays strike here and then goes here, then we will have a different x. So x is variable. So I can say time is basically a function of x. So if I want to find minimum time, I have to differentiate this equation with respect to x. So dt by dx, this will give you, c is a constant, so let us take c outside. Now differentiation of this is 1 by 2 root over x square plus by 1 square, and now you on the top you will have 2x. Similarly here you will have 1 by 2 root over L minus x whole square plus by 2 square, and then you will have 2 times L minus x, and then you will have minus 1 for minus x. Are you getting or not? Now this is the differentiation. If this time is minimum, this differentiation should be equals to 0. Now if you get this, now you see this is what xy. So c goes this that side, you will have 0. xy root over x square plus by 1 square. Now this goes that side, so 2 cancels out, so minus sign goes out, so L minus x and root over L minus x whole square plus by 2 whole square. Now if you see xy, this distance, what is this? Now this is nothing but x by this distance. This is simply sine theta. X by this is sine theta. So I can write this is sine theta 1. So left hand side I have sine theta 1. Now if you see right hand side, L minus x divided by this distance, this is what? Let us see here. You see this distance is L minus x, and this distance is same as that is written in the denominator. So this is basically sine theta 2. This distance divided by this distance. So you will have sine theta 2. So this is written as nothing but sine theta 2. So this implies theta 1 is equals to theta 2. That is nothing but law of reflection. So this is law of reflection. So you see what we are doing. We are proving the law of reflection using the Fermat principle. Even using the Fermat principle, we will derive the law of refraction also. We'll discuss in the next problem. Now you see in this problem what we have done. So what is the Fermat principle? Fermat principle is if a given light ray has more number of paths available from 1 to 2, it will choose the path that will take the least time. And this is obvious. This law is very natural law. Like human being, even if you have too many routes to go from one city to another city, and in that case, you will always choose the route that is the shortest. Given that all the routes have same kind of roads, same kind of traffic. Sometimes we in the life what we do, if traffic is high, we choose the longer route rather than the shorter route because everybody is going to the shorter route. But that is not the case. In ideal situation, assume that all the routes are having same resistance. In this case, you see the same thing also follow the current. If you have in all this, there are so many routes. If there are a route that is have a less resistance, so current will pass through the route that has a less resistance. So that is sometimes called short circuiting, and that is shunt. So let us see what this is. So if I just write here what is short circuiting. So if I have a resistance R, current is going from here to here. Now if I connect this with wire, now this wire will have a very low resistance. So now current will not go through this wire, current will go through this wire. And this is called shunt. You see, here you have a bulb. Now if you connect this wire, bulb will not glow because all the current that is going through this short circuited part, because circuit has become short. That's why this is called short circuiting. Initial circuit is something like big. Now circuit has become short. That's why this is called short circuiting. We'll discuss the next problem. You just copy this one. If you have any difficulty, let us try to do on your own. You will find the answer. And we'll discuss the next problem.